So we're going to go ahead and begin with 2.1, and we're going to look at question number 2. Okay, and what we're trying to do on these is we're trying to find the distance. So we've got two ordered pairs. We've got P, which is 2, 5. That's your first ordered pair. And we've got Q, which is -1, -3. And we want to find the distance. So your distance formula, D, is the square root of x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. Now, when we work with this, we should never have any negative numbers at the end, because when you square a negative, it becomes a positive. So always keep that in mind. You're never ever going to have a negative number underneath that square root, because of the fact that when you square a negative, they become positive. So we'll label x1 and y1, x2 and y2. And then we just fill them in. So we've got 2, and watch out for the double negatives, 2 minus a -1, quantity squared, plus 5 minus a -3, quantity squared. And that's still underneath your square root here. Order of operations says we do the insides first, and then we square. So the double negative makes that a positive. So 3 plus 1 makes it, or sorry, 2 plus 1 makes it a 3. We still have to square that. Double negatives make that a positive. So that's an 8 squared. And 3 squared is 9. 8 squared is going to be that 64. Add those together, and we get what? Square root of 73, I believe. And I don't think 73 will break down any. We could try it. But 3 doesn't go in there. 5 won't go in there. 6 won't go in there. 9 won't go in there. 7 won't go in there, so I don't think that's going to break down at all. So your answer on that one would simply be the square root of 73. Okay. So now we're going to move on then to 2-2. And 2-2 with circles. And we can add more to the list if we need to. But we'll at least review with question number 5. And again, we can add more if we need to here. Now, we want to get these in the center radius form. And this is a new concept. And I'm going to go ahead and move that to 11 over. Okay, so I just went ahead and moved that over, because remember, when we work with these circles, what do we want? We want all the x's and the y's on the left-hand side. Just the numbers, the constants, go on the other side, on the right side. Now we need to complete the square. And we look at each one individually. So let's look at the x part. We've got x squared plus 18x. Now remember, what do? We have to half and square. That's all you have to remember for these circles, is half and square. So we go ahead and half. So what's half of the last number? What's half of 18? Half of 18 is a 9. And then we square it. And what's 9 squared? 9 squared is not 3. Yep, 81. Yep. So we're going to have to add in 81. And we're going to keep track of that. So why are we doing that? Well, we want, for the center radius form, we want these quantities squared like this. Now, what we can do is we can add something on the end to force it to factor. Right? Because remember, 81 is a perfect square. And 81 is a perfect square of what? 9, right? So this would factor into this perfect square trinomial. Now, why do we have to keep track of the 81? Well, because whatever we have to add to one side to make it factor, eventually we're going to have to add to the right side as well. So that's why we have to keep track of it. So we're adding in some number, some constant, to force it to factor. And whatever you do to one side, you have to also do to the other. Now, let's try the y part. And that is y squared minus 2y. So we want this to be a perfect square trinomial as well. And we look in the middle. The middle is a negative 2. So what's half of a negative 2? Half of a negative 2 is a negative 1, right? And if we have 1, when we square 1, it still stays a what? 1. So we're going to have to keep track of the 1 there. So that's what we've got here. Now we can rewrite it in our center radius form. And if we need to, we can do another one of these. Like I can look at 4 as well if we need to. So what do we have on the left-hand side? These are our quantity squared. So we have x plus 9, quantity squared. We have y minus 1, quantity squared. Now we still have a negative 211 left over from the original up here, but we're going to have to add in 81 to force this one to factor and add in 1 over here. And now we can put those together. And we get a negative 129. Now, let's remember, for this to be a circle, the right-hand side must be positive, right? And if it's not, then that means it's not a circle. If it's 0, what does that mean? If it's 0, it means it's a point. When we worked it all the way out to the very end, if this is negative, that, remember, is your r squared. So that would mean r squared equals negative 129, right? And if you try to take the square root to get rid of it, that gives you I. Now, can you ever have an imaginary radius? Is that ever possible? No. So this one is not a circle. And it's not a circle, so what is it? The graph is non-existent. Okay, so the graph there is going to be non-existent because it's a negative number. Let's add one more just to make sure that you kind of see how these are done. So I only gave you a few of these to look at. I only gave you 3 of them. The rest are just working with the center radius form. And that was question 5. And that one was not a circle. And that's why I picked that one. Let's look at 4. Looks like we still need more practice with these, so let's look at question 4. And I'm going to go ahead and move that 12 over. Okay, we could do it in 2 separate steps. You could rewrite it and write it again. I'm not going to do that because I don't want to waste our time rewriting and rewriting and rewriting. So we're going to go ahead and move that 12 over. It was negative, so we move it over as positive here. Now, what's different about this one versus the last one? Well, remember, when we look at these, we want it to be x squared, and we want it to be y squared. We don't want any numbers in front. If there is a number in front, we have to get rid of it, even if that means inducing fractions. So when we look here, we see that these are 2x squared and 2y squared. So we have to get rid of the 2, and so we divide everything by a 2. If there would have been 5's in front, we would divide everything by a 5. So we have to divide everything by a 2. Because there's a 2 in front of the x squared and the y squared. These numbers have to be the same. If one was a 2 and one was a 5, it wouldn't be a circle, it would be an ellipse. And that's something that we don't even cover in this course. That's a later topic for Calculus 1, where you look at ellipses in more detail. So we divide everything by a 2 because it has to be x squared, it has to be y squared. And now I can rewrite this as x squared plus y squared minus 2x plus 6y, and 12 divided by 2 is a 6 there. Now, we want to focus on the x part and we want to focus on the y part separately. So for the x part, we have x squared minus 2x. So what is our technique here? Our technique is half and square. So to force this to factor into a perfect square trinomial, we take our -2, and what's half of -2? -1. So that's x minus 1. And what's minus 1 quantity squared? Minus 1 quantity squared is a positive 1. So we're going to have to add in 1 to force this to factor. It's half and square. That's what we're doing. You can just remember, half and square, you'll be fine. What about the y part? All right, well, on the y part, we have y squared plus 6y. So we have. And what's half of 6? 3. So that comes down and is a positive. So that comes down as a y plus 3. Now, what do we have to add in to make that factor? 3 squared is a 9. So 9 is now going to be added in. Is everyone okay with that so far? So now we can rewrite. So let's see what we've got now. The left-hand side factored into x minus 1 quantity squared, y plus 3 quantity squared, and that now equals the 6 that's already there. Then we're going to add in 1, and we're going to add in 9. So that makes that then 16 on the right-hand side. Okay. Now, unlike the last one, this one will be a circle. How do I know? Well, is the right-hand side positive? Yes. If the right-hand side was 0, it would be a point. If it's a negative number on the right-hand side at the end, that means the graph is non-existent. So this one is 16. Now, let's look at our center radius form. Let's review that one real quick here. This is your center radius form. All right, your center radius form is x plus h quantity squared, y plus k quantity squared equals r squared, and your center is changing those signs. So your center would be minus h minus k, and your radius would be r. So, using what we've got here, we need to find our center and the radius of the circle. So for the center, we always switch the signs. That's our rule. Whenever we go from the center radius form to the center, or vice versa, you switch your signs. So we switch these signs. So my center would be at positive 1, and this positive 3 becomes a negative 3. So my center is at 1, 3. And what about the radius? Well, the radius is r, and this was r squared, so what's ours? 16. So we need the square root of 16, which is then 4. So this has a radius of 4 and a center at 1, -3. So it is a circle because the right-hand side came out to be a positive number, and we were then able to get our center and our radius of that circle. There's only one more left for you to do, and that's question 3. You'll just move that 31 over and work it out the same way. Okay, so that's 5 there. Moving on, we'll look at 2, 3. And these sections are very easy to go through. They don't take a long time. They're pretty quick. A lot of it is review.
For the answer,
Uh-huh.
what would you want?
Yeah, all you really need to do is tell me if it's a circle or not. But we know it's a circle, right? So why don't we go ahead and get the center and the radius? And like on question 5, it's not a circle because that graph is inconsistent, non-existent. Because you can't have an imaginary radius. So this one is a circle, and that circle has a center, and that circle has a radius. But that's what we do, is we go through and we complete the square. We force it to factor. And 2.3, we're going to look at question 2. And the directions are solve for y and replace y with f of x here. And I know we did these in intermediate algebra and elementary algebra as well. We're going to be solving for y. So that's like we're going to be graphing this line. And remember, when it comes to functions, we can replace y with f of x. So we're going to move that 5x over. And then we can divide by a -2. And that's going to help us solve this for y. Negative and negative makes it a positive 5 over 2x. Right? And positive over negative makes it a negative 3/2. Now, what's it say to do? It says solve it for y, which is what we did. And then we want to replace that y with what? F of x. So our final answer would then be f of x instead of y. And that equals 5/2 x minus 3/2. So that's all you need to do for question 2. And there's another one like it as well. I think there's 2 of these. Yep, number 9's the same exact way. A lot of the others are just, is it a function using the vertical line test, or can you solve it for y? That would make it a function as well. There's only one new topic, and that's increasing, decreasing, and constant functions. So we'll just kind of review that before we look at question 10. When we look at these, we need to label these graphs where they increase, decrease, or remain constant. And so we look from left to right. So we look at the graphs from left to right, just like we would read from left to right. If the graph is going up, like this, if it goes up from left to right, then that means this is an increasing function. If it stays flat, that means it's constant. And if it goes down from left to right, that means it decreases. And we have to label on the x-axis, not the y. So on question 10, we've got a picture. And so I'm going to try and draw this graph. The best that I can here. Okay, and this is 1, 2, 3, 4, 5, 6. Okay, so this is our graph here. So when we look at this, we read it from left to right. We think about it kind of like a roller coaster is one way of looking at it. Another way is think about it like a graph on a stock. You want that graph to go up, you don't want it to go down. So we're going to label where it increases, decreases, and remains constant. So if I start here, which is I start at the left. If I start at the left, what is it doing as I follow the blue graph down? Okay, so this is the decrease part. Then it's constant, right? And then what does it do after that? Increases. So this is the decrease, this is the constant, and this is the increase. Now, we do not label on the y-axis. We label it based upon the x-axis. So don't even label the y at all, only label the x-axis. And the x-axis, where it changes, is going to be at -3 to 3. If you read it on the tick marks there, looks like it changes from -3 to 3. And of course, back on the left is negative infinity, and back to the right is positive infinity. Now, we need to get where it increases, where it decreases, and where it remains constant. And the easiest one to probably get is where it's constant. So where is it going to be constant from? Yep. -3, we use a square bracket, to +3. Actually, they use parentheses in this case. Yep, because it changes that at that point. So we're going to use parentheses on those. Now, what about the decrease part? Okay, so this is the decrease part here. Now, when we look at the decrease part, we label it on the x-axis. So where does it start decreasing from? It starts decreasing from negative infinity. And where does it stop decreasing? -3. We label it on the x-axis. So it decreases here, right, going down. And that's from from negative infinity to -3. Where does it increase from? It increases from what?
Negative.
Well,
Or,
yep, +3, right? And where does it go? It's still increasing all the way up to what? Positive infinity. So which one does that look like? Looks like it's going to be answer what? Answer A, isn't it? Yep. Because you got to watch how they're labeled here and make sure they're in the right direction. Okay, and why would B not work? Okay, B is just different, right? It's not labeled the same way. Yep, so it has to be A, isn't it? Because it increases from 3 to infinity. It decreases from -infinity to -3. And then it's constant from -3 to +3. So it looks like that one would be answer A. And the same logic is going to apply to question 3. Only difference is when we look at question 3, is there any spot where it's constant? No. So there's not even a constant part. And I made it multiple choice so it would be easier for you to work on this and get the intervals correct. Because otherwise students make a mistake. They try to label on the y instead of the x. So that's why I made those multiple choices there. And 2-4 should have been a complete review of slopes. I am going to look at one question, one of these multiple choice questions, just so you remember how these work and what I'm kind of looking for here. So 13 through 15 are all a little bit different. But on 14, they want a y-intercept of 2. Or sorry, of negative 2. So here's our choices, and we're going to go through each one. And we're going to use process of elimination to see which one of these has a y-intercept of a negative 2. Okay, so here's our choices. We're going to talk about all the choices. Now, you can probably already tell that the third one is going to be the correct answer, right? Because it has a negative on the end. When it's been solved for y, or it's f of x, that is your b, and that is your y-intercept. That would have a y-intercept of 0, negative 2. Because it's been solved for y, or f of x. They're the same thing. Now, what about the first one? Why does the first one not work? What would the y-intercept of the first one be? Okay, this has been solved for y, so the y-intercept would be what? What's the number on the end? 3. So that would be a y-intercept of 0, 3. We want a y-intercept of negative 2. So that one's not going to work. What about the second one here? Well, we're going to have to solve that for y. So we're going to add the 2 over. And then we've got 8y equals 2x plus 3. We divide by our 8 everywhere and we reduce. So y equals then 1/4 x plus 3/8. And so this one would have a y-intercept of what? Yep, 3/8 comma, or 0, 3/8, because we write them as ordered pairs usually. And so it's not going to work, is it? And this one doesn't even work. Why not? It's an x line. It doesn't even have a y-intercept. So this one has no y-intercept. So that one doesn't work either. So the only one that has that y-intercept of a negative 2 would be what? Would be C. And question 13 says, which one's a constant function? Well, what makes something a constant function? It's a constant function if it has no x's in it. So you can look at 13 and see, clearly one of these is different from the others, and it can't have any x's, so that's going to be the constant. So there's only one of those. What about 15? You want a positive slope. And so you're going to have to solve each one of them for y, and then look at the number in front of the x. Now, if it's like x to the 13th power, it's not even a line anymore, so it doesn't have a slope at all. So it's not a on 15, it's one of the others. So that's what we covered last time. Was we covered 2-1, 2-2, 2-3, and 2/4. Today, we're going to be trying to finish up this chapter. And like I said before, this chapter is a lot faster to go through than chapter 1, because chapter 1 is building all the skills that we use for the later chapters. 2/5 is going to be a review of what we have covered in previous courses. Nothing new with 2/5, it's all just a review. And in 2/5, we need to remember, first off, how to write a line. And there are two ways to write a line. So there's two ways that we can write our answers on these. There's the most common one, which is slope-intercept, which slope-intercept is y equals mx plus b. And then there's also standard form, which is ax plus by equals c. A must be positive. And also, no fractions and no decimals are allowed. So if we remember from previous courses, how do you write your answer? Your answer has to be in either slope-intercept or it has to be in standard form. And it's going to tell you which one it needs to be in. And when we work these type of questions out, there are three different problems that we may encounter. How to get these line equations. You can get them from having a point and a slope. You can get them by having 2 points, or you can get them by having a point and another line equation. And so the way I present these, remember, is by using a flow chart. So we're going to go through these flow charts here. And we're going to start with how to find the equation of a line when you're given a point and a slope. So we want to find the line equation when you are given a point and you're given a slope. So this is a flow chart. Now, when we are given a point and a slope, there's only one step that we have to do. And that is we're going to use the point-slope formula. And that is y minus y1 equals m times x minus x1. And then once we've used this formula, then we can either write our answer in slope-intercept form, which is y equals mx plus b, Or we can write it in what's called standard form. And standard form is ax plus by equals c. So these are the two ways that we can express our answers. And if you'd like, I'll write these up and give them to you in a handout after break. So once we take a break, I'll rewrite them again on a piece of paper so you can have them. And you can use these on your final. We're not going to have an exam over Chapter 2, but we are going to have a final that will have a little bit of everything. So it'll have Chapter 1, Chapter 2. It's going to have a little bit out of 3, or sorry, 4 and 5 as well, because we don't cover much in Chapter 3. We're going to be covering those next week. So this week, today, our goal is to get through Chapter 2. Next week, we're going to be covering some more material out of 4 and 5, and then we'll be preparing for our final exam. So our final exam is going to be in 2 weeks. So we have a few class periods left, but not a lot really. So now let's try to work through one of these. We'll do one in standard form and one in slope-intercept form. So we'll work with one in standard form first. And we'll do one with a fraction. Sometimes students struggle with these because they forget the step-by-step directions. So first thing I always look at whenever I'm in this section, regardless of what class it is, whether it's elementary, intermediate, or college algebra, we all cover the same topics when it relates to lines, is I say, what do I have? Okay, what am I given? I am given a point and a slope. So if I am given a point and a slope, this is the easiest one, and all I have to do is use the point-slope formula. We'll do 2 of these, and then we'll take a short break. And then come back and finish up this section. So we're going to be using the point-slope formula. And when we talk about the point-slope formula is y minus y1 equals m times x minus x1. And so we label our ordered pair x1 and y1. So all we have to do is plug our numbers in. Now, be very careful about double negatives. So we've got y, and then we do minus, a minus 8, equals now minus 4/7 times x minus 5. So that's what we've got. Now we are going to put this in standard form, so we are going to have to eventually clear out all the fractions. So we'll begin with a double negative here. That's going to make that a positive 8. And then we simply distribute that minus 4/7 through. And that's going to be a minus 4/7 x. Double negative makes it positive. 5 times 4 is a 20, so that's positive 20/7. So we distributed through. Now, we are in standard form. Can we have fractions in standard form? No. So let's go ahead and get rid of these fractions. Well, to get rid of the fractions, it looks like we have a common denominator of a 7. And so we're going to have to multiply everything now by a 7. Take your time, make sure you don't make an algebra mistake on these. That's where students a lot of times make a mistake, is in the algebra. So be careful with the calculations. So we have 7y, we have a 56 equals, those cancel, a minus 4x, those 7's cancel, leaving you with a positive 20. Now, what form do we want this in? Standard form. So the x's and the y's have to be on the same side. So moving this to standard form, I'm going to add 4x, and I'm also going to subtract off that 56. That way we have everything that we need on the left-hand side, which is 4x plus 7y. And then on the right-hand side, it looks like we have a 36, because 20 minus that 56, that makes it a minus 36 there. And that would be your answer. And again, they're not really difficult, they're just tedious and time consuming. That's all these are. It's easy to make a mistake in the calculations. But you just take your time, try to be organized, neat, and you won't have any trouble with these at all. So let's do another one, and then we'll take a short break. So let's find the equation. In slope-intercept form. Okay, so we're going to try to find this equation in slope-intercept form. And you're going to be given the point 3, 9, and a slope of negative 4. Okay, first thing I do is I look at it and I say, what do I have? I have a point and I have a slope. So now I know where to begin. Point and a slope, I associate that with point slope. So I use point slope. And that is y minus y1 equals m times x minus x1. And we label our ordered pairs x1 and y1. So just like the last one. Now the only difference is this one's actually a little bit easier because we're going to get it in slope-intercept form. And there's no fraction. But it's the same as what we just did a moment ago. So now we simply fill it in. And that's y minus 9 equals minus 4 times x minus 3. And we're distributing this negative 4 through. So that's y minus 9 equals a minus 4x. Negative and negative makes it a positive 12. Now, what do we want this in? We want this in slope-intercept form. So all we have to do to get it in slope-intercept form is add that 9 across. And now we've got it because y now equals a minus 4x. And 12 and 9 makes it a 21. So let's go ahead and take a short break, and we will meet back here at, let's say, about 9:55. So we'll be back here in about 10 minutes, and we'll finish up this section.